All right, welcome in. Going to take a look at things. So let's take a look. So we're looking at beginning algebra. We're moving on from the factoring, solving equations chapter. So solving quadratic equations by factoring. And then all the factoring techniques that we needed along the way to get there. Oops. That just timed out. Let me fix this. Okay, so where was I? Oh, right. We wrapped up the chapter on factoring and solving equations using factoring. So we're now beginning the last chapter of the course, which is rational expressions. It is more complex than what we've been doing. And not to say easier or harder. I'm not saying easier or hard. I'm saying simpler versus complex. So the factoring problems you've done would generally take sometimes one line, right? If it's a trinomial and it's a simple one, sometimes you factored it in one line, right? You got it. If you're doing factor by grouping, then maybe it took you 2 or 3 lines, but most of these problems only took, 2-3 lines in order to complete of work I'm talking about. In this section, you're going to be writing a lot more, so just get comfortable with that. You want to be writing more because if you don't, there's just a lot going on in these problems. So, you'll be getting into problems where you might be writing 5, 6, 7, 10 lines or so in order to finish a problem. So just sort of get comfortable with that. I know it takes a little time. It's like reading, right? When people start reading, they're really slow and it takes them a long time to finish a page. And then after a couple weeks, they're like flying through books, right? It's the same thing with writing this stuff out. It may seem tedious at first. You're going to pick it up quickly. You figure out what you're doing and move along pretty well. So rational expressions are also, there's more going on with them that we have to think about. But there is good news, right? And this good news may actually scare some of you, considering that the fear that many people carry around of fractions. But that is that rational expressions are really just fractions made of polynomials. So this is good news because fundamentally what it means is that the rational expressions are going to behave largely like fractions that we're used to. There's a little bit more going on. It's a little bit more complex than just calling them fractions, but ultimately they're fractions. So that's great because that means you get to lean on your knowledge of fractions throughout this chapter. So when you're doing a problem and you go, how do I simplify a rational expression? Just think, well, how do I simplify a fraction? Well, the way I simplify a fraction is I divide the numerator and the denominator by any common factors. Oh, that's what I do for a rational expression as well. And then, yeah, the actual process will be a little bit harder because factors of a number are a little easier to find than factors of a polynomial. But fundamentally, you're following the same process, right? So this is kind of a combination of all your previous knowledge about fractions that you learned in pre-algebra and that you've worked on along the way through this semester, getting more comfortable with fractions. And we're combining that with the previous chapter on factoring. Put those two chapters together and you have this chapter. So that's good. Like, there is new stuff to learn. We're doing stuff in new ways. But fundamentally, you already know a pretty large portion of the things you need to know for this chapter. And you'll see that when I'm introducing concepts, I'm first going to talk about it in terms of just a normal fraction with numbers in it. And we're going to discuss a topic. And then we will carry that topic over to rational expressions. And you'll see what I'm saying where you go, oh, I see. We're thinking about this fraction in the same way. But there's a couple extra details we have to think about because they're polynomials and not necessarily numbers. Okay, so you'll hear me talking about both about numbers, just typical number fractions, and rational expressions, which are polynomial fractions. Okay, fractions of polynomials. So let's remind ourselves, let's see, a normal fraction. Well, there were some fractions that we couldn't use, right? So there are two situations that would arise. In fact, I'm going to do this up here where I think I want the font to be a little bigger. So let me do it up on this page where I have the font enlarged. So let's consider two situations. One is where we have the fraction 0 over 3. And then one is where we have the fraction, if I could hit buttons correctly, where we have the fraction 3 over 0. Oh, there we go. Okay, that might be too big, but we'll see. Let me see if I can get a better size here. That looks a little better. Okay, so two types of fractions we can end up with. I can have 0 in the numerator, or I can have 0 in the denominator. One of those perfectly acceptable. One of them is nonsensical and doesn't even mean anything, right? So what you want to do is be able to keep track of which one's which. It's pretty important. So hopefully you're sitting there now going, I know which one of those is 0 and I know which one of those is undefined. If you do, that's great. You're off to a great start. If not, that's okay. You're just gonna have to really get yourself comfortable with what it means to have 0 in the numerator, what it means to have 0 in the denominator, because it's going to keep coming up throughout the chapter. You're going to keep seeing it. So that's why I want to cover it, so that we can break it down now and you can go, oh, that's how I'm supposed to think about it. Because sometimes you learn a math concept, you don't look at that particularly for a year, and you kind of forget the way in which you're supposed to think about a certain type of problem. So let's think about 0 over 3. What does this mean? Okay, the fraction 0 over 3. So think back to like the 3rd grade when you were first learning fractions, right? And what would they tell you? Well, 0 over 3, if we interpret that as a fraction, then you would like draw your pizza, right? There's different tools for learning this, but maybe it's a pie or a cake. But okay, you got your pizza, that's your circle, and you cut it into 3 equal pieces. That's what the 3 in the denominator is. We take one whole and we break it into 3 equal pieces. So imagine kind of like the peace sign or something, where you've got a circle, and then we've split this into 3 equal pieces of pizza. And of the 3 equal pieces of pizza, you eat 0 of them. So we've taken a pizza, we split it into 3 equal pieces, and I don't eat any of the pieces. That's 0 of 3. I ate 0 of the 3 pieces. I keep trying to want to say pizzas. I ate 0 of the 3 pieces. Well, then how much pizza have I eaten? 0. I've eaten 0 pizza, right? So having 0 in the numerator is perfectly acceptable, and it simplifies the whole fraction to 0. Because if I had 0 of 3 pieces, that's the same as having 0 of 5 pieces, or 0 of 7 pieces, or 0 of 139 pieces. It doesn't matter. If the numerator is 0, then I've had 0 pizza, right? And we will do problems. See, one of the mix-ups that people have in this chapter is that there is going to be times when we set numerators equal to 0, and there's going to be times when we set denominators equal to 0. But the outcomes mean very different things. So you have to remember to interpret, okay, what does 0 in the numerator mean? Okay, what does 0 in the denominator mean? And then you have to make those interpretations as we go. Okay, so pretty straightforward. Cut my pizza into 3 pieces. I eat 0 of them. I've eaten 0 pizza. Okay, now this looks like a perfectly legitimate fraction, but try to construct that same narrative, and you'll see that this is just nonsense. This doesn't even mean anything, right? So this would be a situation where I take my pizza, it's sitting in front of me, one whole pizza, and I cut it into 0 pieces. So we're already in trouble. Like, what do you mean I take a pizza and I cut it into 0 pieces? It's already one piece. It's one giant connected whole pizza. It's one piece. How can I cut something into 0 pieces? Right? It already doesn't make sense. Okay, let's continue. I take my pizza. I cut it into 0 equal pieces. Okay, already confused. But of those 0 equal pieces, I eat 3 of them. This is all nonsense. It's like I'm saying things that don't make sense. I've taken a pizza, I've cut it into 0 pieces, and from those 0 pieces, I ate 3. It doesn't mean anything, right? So that's the one that we call undefined. So that's your proper answer when you see something with 0 in the bottom, is that fraction is undefined. What does undefined mean? It means we haven't defined it in mathematics. And, you might go, well, why don't you just define it then? I remember literally asking my teacher that when I was in, wherever it was, high school or something, like, well, why don't we just define it? Like, why has no one gotten around to defining this? What I've since come to understand as I pursued more mathematics, it's undefined because it's just meaningless. That's the mathematical fancy way of saying this doesn't mean anything. There is no definition we can attach to it because it is meaningless nonsense, right? So even though it looks legit, 3 over 0, it's really mathematically nonsensical. It would be like we could create a word or a sentence. I could take a sentence. We'll start with a capital. We'll end with a period. But if we just randomly select words in the middle, even if the punctuation's right, and even if the capitalization and everything is right, when you first look at it from across the room, say it's on a whiteboard, and you walk in the room and you look at it and you go, oh, there's some sentence on the board. But then when you read it and it just says like book, house, shoes, water, and you're like, what? What does that mean? It doesn't make any sense, right? It's just a bunch of nouns, but it's made to look like a sentence. That's kind of what we have here. This is made to look like it's mathematically meaningful, but in fact, it is undefined. It doesn't mean anything, okay? So that is important to us because this is a concept that's going to come up regularly throughout this chapter, is determining when is the numerator 0 and what does that mean for us? When is the denominator 0 and what does that mean for us? So you want to be good at going back and forth. Excuse me. Going back and like understanding these two possible ways of writing a fraction, okay? So here's the thing. When we have a fraction of numbers, it's real obvious to see where the zeros are. Oh, well, here's 0 right in the numerator. I can see it's 0. It's not like hiding. There's nothing to figure out. It's just right there. And here I can see 0's right in the denominator. Well, there it is. What's there to discuss? There's a 0 right there in the denominator, so it's undefined. It's pretty straightforward. We're going to take that same idea, except we're going to have a little bit more to put on there. So let's take, for example, if I have the fraction 2x plus 3 over x squared minus 1. Let's see, how big is this going to be? That's big enough. I think that looks good. Let me double check here when it shows up on the stream. Yeah, okay. That's big enough. We can work with that. So, in fact, let's see. Let me change the formatting here. Okay, so now we have a fraction that's composed of 2 polynomials. This is our first rational expression. So we have a rational expression here. And you might look at that and say, uh-oh, what happened? You might, as soon as it corrects here. So you might look at this and say, okay, 2x plus 3 over x squared minus 1. Well, I don't see a 0 in the numerator, and I don't see a 0 in the denominator. Basically, the bottom line is when we deal with a rational expression, we always want to know if it's going to have a 0 in the denominator. You always want to know that. There's never a time when it's like, we don't need to figure that out. I mean, there may be, but it's always a good idea to figure out what it is. Okay, so you look at it and you say, well, I don't see 0 in the numerator, and I don't see a 0 in the denominator, but careful, the value of the numerator or the denominator depends on what x is. See, that's different than up here where we just had numbers. Nothing was changing. Nothing was varying. There was no variable, right? 0 is 0 and 3 is 3. So that's what those fractions were. But down here, the numerator changes depending on what x is. For instance, if I plug in 0 for x, then the numerator is 3. If I plug in 10 for x, then the numerator is 23, right? We get a different value. What about for the denominator? Well, what if I plug in 10? Well, then the denominator is 99. What if I plug in 7? then the denominator is 48. Well, the thing we want to know is the denominator ever 0? Because if we plug in a value for x and the denominator becomes 0, now we have an undefined value, and that's a problem, right? We need to be careful about that. So how could I possibly figure that out? Well, the way you say it to yourself is literally how you solve it. So I look at this fraction and I go, I need to know when the denominator is equal to 0. So what do? You literally set the denominator equal to 0. Like it's almost like the answer to how you do it is embedded in the original question. How do I figure out when the denominator is 0? Set the denominator equal to 0. So what would that mean? We would set x squared minus 1 equals 0. And then I would solve this equation. So I'm setting the denominator equal to 0. I'll put a note here. Set denominator to 0. Right? So I'm setting the denominator equal to 0. And then when I solve this, right, I'm going to get what? It factors as a difference of squares. So I'm going to get x plus 1, x minus 1. Hopefully you're pretty comfortable with that by now. So when I go to solve that, I'm going to get what? X equals negative 1 or x equals 1, right? So let's see if I did that right. Okay, so I got x equals 1 and x equals negative 1 when I set the denominator equal to 0. So what happens when I go back and plug 1 into this rational expression right here? Well, when I plug 1 in on the top, I'm going to get 2 times 1 plus 3. That's 5. So 5 in the numerator. 1 squared minus 1 is 0. 0 in the denominator. So that value is undefined. It doesn't even matter what we get in the numerator in this case because the denominator being 0 wrecks the whole thing, right? Okay, what about negative 1? If I plug in negative 1, I get 1 on top because it's negative 2 plus 3. And then once again, I get 0 in the denominator. So that means that this rational expression is undefined when x equals negative 1 or when x equals 1. So now we know the points that are going to give us a problem. I can plug in any x value I want to this rational expression and evaluate it. Remember, evaluate is just a fancy word that means plug in a value for x. So if I evaluate this rational expression when x equals 1, I get 0 in the denominator. Same if it's negative 1. Okay, so let's see how they ask this on the homework, because you should be aware, like I'm going to go over how they do it in the homework, but you should be aware when you go to other math classes, when you go to Math 3, Intermediate Algebra, when you go to Pre-Calc or College Algebra or Trigonometry, they ask these same questions but in a different way, right? They can ask, when is this rational expression undefined? They can ask, when is this rational expression defined? They can say, what is the domain of this rational expression? Domain is just a fancy way of saying what x's can I stick in there. That's the same as saying, where is it defined? They can say, there's different ways of wording it, but they all come down to the same thing, which is set the denominator equal to 0 and solve it. So let's remind ourselves how they do it on the homework that you're going to be doing. So they ask the kind of the preferable way. For which values of x is the expression undefined? Okay, so you've been given 9x plus 63 equals 9x minus 7. Okay, we'll get to simplifying in a little bit. What you cannot do is just draw a line through these 9x's and go, oh, good, let's get rid of those. Not going to work. So we'll go over that here in a little bit. So for which values of x is the expression undefined? Undefined means 0 in the denominator. Okay, so let's write this down. Let's go to a new page here. So it's what? It's the fraction 9x plus 63, I think, over 9x plus 7. Is that what it was? 9x minus 7. So 9x plus 63 over 9x minus 7. Okay, I want to know when this is undefined. Well, undefined means 0 in the denominator. Okay, so if it's 0 in the denominator, then I should set my denominator equal to 0. Okay, So I'm going to do that. And I'm going to get 9x minus 7 equals 63. Oops. Sorry. I don't know why I said that. I was looking at the 63, and then for some reason I wrote it. 9x minus 7 equals 0. So I took my denominator, and I set my denominator equal to 0, because I want to know, when does 9x minus 7 equal 0? When it does, I'm going to get 0 in the denominator. Well, it looks like we're going to get a fraction. That's okay. The whole chapter is fractions. Literally everything in this chapter is a fraction. So 9x equals 7. When we divide, I'm going to get x equals the fraction 9/7. So x equals 9/7. So let's go back and see if I did that right. 9/7. Uh-oh. Okay, what did I do? Oh, is it supposed to be? No. Let's see. Oh. Yes, I was messy. It should not be 9/7. It should be 7/9. Because I'm dividing by 9, right? So trying to sometimes when you're explaining something at the same time you're trying to calculate it is not good. So yeah, this should have been 7/9. There we go. So let me change this to 7/9. That should do it. There we go, and we got it. So it's the same thing they're saying. Just set the denominator equal to 0. Notice that we never did anything with the numerator, because for this particular question, we don't care about the numerator. The numerator does not affect whether our fraction is undefined or not. Now, plenty of other problems will need the numerator. So sometimes you'll go, oh, well, you said that only the denominator matters and not the numerator. I said that for when we're finding if the thing is undefined. So yes, other parts of the chapter, the numerator will obviously play an important role. Otherwise, if it didn't make any difference, we wouldn't put it there, right? So the numerator is important, but not for problems about undefined. Undefined, you only care about the denominator. So they take the denominator, set it equal to 0, solve, and then you're done. Okay. Let's see, what's the next one look like? Yeah. Right. So that's all you do for these kind of problems. Set the denominator equal to 0, solve the thing, see what you get. Okay, the next big thing, which sometimes people find challenging, is simplifying. So let's just recall what we do with a fraction. How do we simplify a fraction? So let's just say that I had the fraction 24/18, and I knew I had to simplify this fraction. What am I doing? Well, a lot of times people use the word cancel. I encourage you to not use the word cancel, because cancel is like a magic word. What does it mean? What does it mean to cancel something, right? Canceling is not really a mathematical operation. So what is happening when we cancel? Well, what you're really doing is you're dividing the same factor from the top and bottom. So I look at my 24 and my 18, and I ask myself, what do they have in common? What is the biggest thing that these two numbers have in common? And the answer is they both have 6 as a factor. 18 is 6 times 3. 24 is 6 times 4. So 6 divides both of these numbers. So I divide the top and bottom of the fraction by 6. See how it's different when I use the word division versus canceling? Canceling means different things in different scenarios, but division means division, right? So when I say divide, we know that's literally a legitimate mathematical operation. If I say I divided the top and bottom by 6, you know exactly what I did. If I say cancel, then people do different things and call it canceling. Okay, so if I divide the top and bottom by 6, then I'm going to get 4/3. Right? So that's how we simplify a rational expression. So let's take, for instance, let's jump into a rational expression then and try to simplify this thing. Okay, so we're going to use the same process here. I'm going to look at that. I'm going to divide the top and bottom by the same factors. That's what we did for 24/18. We divided the top and bottom by the factor 6, and we got our final answer. I'm going to do the same thing here, except there's a problem, right? Most people, when they look at 24/18, can start to figure out some factors. At the very least, you know 2 is a factor, and you divide that out. Some people see 6 as a factor right away, and you divide that out. Anyways, you'll eventually get to your answer. Looking at this fraction that we have, x squared minus 16 over 2x squared plus 8x, what are the factors? I don't see the factors when I'm looking at it. Well, you just completed a whole chapter on factoring, so guess what you're going to do if we want to know the factors in this rational expression? That's right, you're going to factor them. Tons of this chapter involves you factoring. Okay, I know a lot of times people are like, well, we finished the factoring chapter. Why do I have to still keep factoring? The whole point is that we're learning tools that we're going to need later down the road. So you're going to have to factor these. So that's step 1, factor. Like, that's a lot of things in this chapter. Step 1 is going to be like factor everything you see. So if I do that, okay, so the top is a difference of squares. So that's going to be x plus 4 times x minus 4, right? And then the denominator, let's see. We've got an x and a 2. So it looks like I can take out a 2x, which will leave me with x plus 4. So now all of a sudden I go, oh, look, there's common factors in there, right? See how it wasn't obvious at the beginning that they had common factors, but now it is. I see an x plus 4 in the numerator, and I see an x plus 4 in the denominator. So what am I going to do? A lot of times people say, oh, you're going to cancel those. Yes, I'm going to cancel them. But more specifically, I'm going to divide the top and bottom of this fraction by x plus 4. Okay, so we go, okay, that's going to equal the fraction x minus 4 over 2x. Okay, looks like that's what we should, yep, that's what we should get, x minus 4 over 2x. There's no more simplifying that can occur. This is a fully simplified rational expression. So we started with something that needed to be simplified. How did we determine the factors? We factored. Once we factored things, we could identify that there's a common factor in the top and bottom. So we divided that out, and we get x minus 4 over 2x. Okay? So this would be our simplified version. Now, there's a little bit, technically what I have written here so far is a little bit of a lie. So normally what we want to do is we want to put a little bit of a note in here after this problem. Because technically this fraction at the beginning is not exactly equal to this fraction at the end, right? And here's why. This first fraction is undefined when x equals -4, okay? But this last one's not. Because technically when we canceled these factors out, we eliminated one of the ways that the denominator can become 0. So technically we have to say these are equal, but we have to make a little note and say when x is not equal to -4. This is how you'll see it like in books and stuff. They'll say these things are equal, and then a little note at the end that says when x is not equal to 4. Let me move it over so you can see. okay? Because as long as we're not worried about the point x equals -4, then these two things are identical. But at x equals -4, this thing is going to be what? -8 over -8. It would be 1, whereas this one will be undefined. So we have to be a little careful about that, okay? Most of the time, we're just going to go ahead and simplify these things down and not worry about writing when x equals -4, but you should be aware of that. You should be thinking about it and going, oh, there's a domain restriction now, right? The domain is just all the places where your function is defined. So it's back to that same way of saying the domain is really a different way of saying where's the function defined. And where is a function defined? Everywhere that it's not undefined, which sounds like kind of a silly statement, but that's how you do it, is you find the places where a function's undefined, everywhere else it is defined. Okay. Now, why am I making such a big deal about division? And I keep saying we have to divide, right? I keep saying we're not canceling, we're dividing. And it's for reasons like this. This is a very common thing in mathematics. In fact, I saw it was kind of a clickbait video on the YouTube channel. When I pulled it up, it was trying to get me to watch a video with an example like this. And it was like, you know, that's a ridiculous kind of thing they do in clickbait news articles and stuff where they're, or ads where they're like, 99% of people do this. Can you get it right? And it was like 99% of people get this wrong, which I think is excessive. A lot of people do this wrong at first, and then once they're shown, they stop doing it. But people will keep making this mistake again and again. So you don't want to do it, but the way it was presented in that video was a little silly. Equals. So the common mistake here is to say, oh, I have an x plus 4 over an x, so why don't I cancel the x's? And this is why I don't like you using the word cancel. Because when you say cancel, again, what does that really mean mathematically? Like, it's an English word that we use, but canceling as far as an actual defined mathematical operation is a little sketchy. Especially since the x here in the numerator is connected to the 4 by addition. Up here, we divided out the x plus 4s, but we could divide out the x plus 4s because the x plus 4s were connected by multiplication. So multiplications and divisions are used to undo each other, right? But down here, my x is connected by a plus. So if I came in here and said, I want to cancel those x's, well, instead of using the word cancel, think about it in terms of the word division. I want to divide the top and bottom by x. Well, if I divide the numerator by x, is that going to undo an addition? No. Divisions are done to undo multiplications. So it just doesn't make sense. So you can't come in here and cancel these x's out and say, oh, I'm left with 4. Like, that's the common mistake that people do, is leave it with a 4. But in fact, that fraction is fully simplified. It's not going to get reduced any simpler than it already is. Like, that's x plus 4 over x. That's as small as you can get it until you plug numbers in and start evaluating it. Then you could maybe simplify those fractions. But don't just try to cross these x's out. You divide. Always think of it as a division, and then you're not likely to mess it up. Okay, let's see how they ask. Let's see, we did that one. Let's see how they ask over here. Oh, here's where I meant to go. Simplifying rationals. Okay, so what would I get? I want to simplify this. So 2x squared over x cubed plus x squared. Let's look at that one. Two x squared over, what was it? X cubed plus x squared. Okay, so this, I believe, is the problem we're supposed to simplify. Okay, so what do? Factor everything. That's pretty much going to be, your mantra for the chapter. Whenever in doubt, just try factoring everything. Okay, so when I do that, I'm going to get, the top can't be factored. It's 2x squared. And then we're left with an x squared times x plus 3. No, not x plus 3. X plus 1. Don't know why I said 3. Okay, so the numerator is left the same. We've factored the denominator. If I factor that, or if I multiply that back in, I get x cubed plus x squared. So what do I have? Do I have factors I can cancel? Well, I see an x squared on the top, and that x squared is connected by multiplication. Good. I see an x squared in the bottom, and that x squared is connected by multiplication, meaning that I can rid them. I can rid our problem of those x squareds by dividing the top and bottom by x squared, which gives me, let's see, that's going to leave me with a 2 on top, and that's going to leave me with an x plus 1 on bottom. So I think this should be 2 over x plus 1. Let's see, 2 over x plus 1. And there we go. So same thing. They factored the top and bottom. Cancel it out, we get our answer. Okay, and I want to show you something here. Let's do this one as well, because this one confuses people. So what if we've got the following fraction? Okay, so let's just say you're told to simplify this, and you go, okay, well, I don't see any common factors, but I better factor everything so that I can really see what my factors are. Okay, so we factor the top and bottom, x plus 3. If I factor the bottom, I get x plus 4 times x plus 3. Okay. We go, oh, there's an x plus 3 on the top and bottom. Again, this is another example of a common error that I see that you can get around if you just train yourself to use the word division instead of cancel. Because again, cancel is this weird nebulous thing. What exactly does it mean? Division, we know exactly what it means. And here's the mistake people make. They get the bottom right, and they know that the thing that should be left on the bottom is x plus 4, because that's the x plus 3 cancels out, right? And then they go, well, the x plus 3 canceled out from the top, so don't I have 0 left? And I'll see an answer like this. 0 over x plus 4. And they'll go, yeah, because I canceled the x plus 3 from the top. So if the x plus 3 is gone, nothing's left, so that means 0, right? No. We divided x plus 3 by x plus 3. What is anything divided by itself? It's 1. So there should still be a 1 in the numerator. And there it is. Okay, so just watch out for that. When you're canceling the factors in the numerator and denominator, if you're dividing it out and nothing's left, then you really should have a 1, because that last factor, you divided it by itself. Anything divided by itself is 1. Okay. What about this? This one looks scary, right? Oh my gosh, look at this thing. This same game. You're just going to factor the numerator, factor the denominator. So let's take a look at it. Let's work this one. Whoops, it's 15, not 16. Let me fix that. X squared plus 15x plus 56. X squared plus 6x minus 16. So x squared plus 6x minus 16. Okay, let's set to factor, or to simplifying this thing. Okay, so step number 1, factor everything you see. Okay. Right, you're going to hear, like almost every lesson, there'll be times when factor everything in the problem, and that's what we got to do. So let's see. How are we going to get the top? That looks like it's probably x plus 8 and x plus 7. Okay, and the bottom is going to be, let's see, x plus 8, x minus 2. Okay, now that I've factored the whole problem, I can see what my factors are. Oh, I have an x plus 8 in the numerator and x plus 8 in the denominator. They're connected by multiplication, so I'm free to divide them out. So once I do that, I end up with whatever's left, x plus 7 over x minus 2. So let's see. X plus 7 over x minus 2. And there we go. We got it. See? So same thing I did. You take the thing, you factor it, cancel out the common factors, boom, there's your answer. And that's how it goes. Okay, so we'll leave off with that, with simplifying those expressions, because from here it gets a little harder. This is like the preliminary stuff. From here, it's going to get a slightly more complicated. Oh, do I not have a canvas shell open? Let me see. I should be able to do this if I get in there. And I get into canvas. And I want math 1. So let's see. Let's just remind ourselves where we are. Right. Make sure you do. Oh, that one already passed. So we're into this last one. So, yeah. Okay. That's where we're at. So, oh, right. Because this is the. Oh, I can't go to the assignments because then I'll expose everyone's grades. So let's see. What if I do it this way? Here we go. Let's go to math 1. This will work too. So we kind of did these first ones, simplifying rationals. You should be able to do these 3 parts, definitely. The multiplying and dividing, if you wanted to, like if you're like, you know, I'd rather just finish this over Thanksgiving weekend. I just want to get this stuff done. You probably, a lot of you, if you're a little bit dedicated, you could probably finish this whole assignment right here. I will talk about multiplying and dividing next time, but honestly, I think a lot of you could pick it up if you wanted to get that completed, and then you'd only have a couple things to do when we get back. The adding and subtracting is a pain. Could some of you figure out the adding and subtracting on your own if you wanted? Yeah, you can, because again, it's the same way you add and subtract actual fractions, except like things like finding a common denominator is a little bit harder because you're talking about polynomial factors in your common denominator, so it's a little bit trickier. But again, fundamentally, you know how to do all this stuff. You just haven't seen all the pieces brought together. So if you wanted, you could finish up basically the homework for the you know, if you wanted to work ahead, you could move through a lot of this stuff. And we'll talk about solving rational equations. And some of those get messy and be kind of a pain, but we'll see how it goes. So you feel free to work ahead if you want. Otherwise, I'll cover as much as I can when we get back from Thanksgiving break, and then we'll go over stuff then, okay? So anyone who wants to talk to me, hop over into Zoom, and I will talk to you about whatever you want. Otherwise, I'm closing the YouTube stream down, and we'll just move it into Zoom if you have questions for me. Okay, thanks, everybody.